Hi guys, welcome back to All Things Nautical. In this video we'll be having a look at finding the time, the GMT and also the zone time for a heavenly body, which is in this case again the Sun, at lower meridian passage. Now the observer still remains stationary, which means it's not too different from the calculations we've done before. The only real difference here is that the LHA for the body, instead of being 360 or 0, which is the case at upper meridian passage, in this case with the body being on the meridian that is actually 180 degrees apart from the observer's meridian, so the opposite meridian, this LHA in this case will become 180 degrees, and that will always be the case when we're dealing with lower meridian passage. It will always be 180 degree LHA. So again, we're going to be following the same kind of structure. We'll be finding the approximate time first, both GMT and also the time at the observer, or at the ship in this case. Then we'll be calculating our time increments over here, and that will then go over into the actual calculation to the nearest second for the observation of that body. So all the information is again given here, just like before. We have a date, which is in this case the 13th of August. Now again, we must note that this 13th of August here, this date is actually the date at the vessel. So this is the date that the observer sees the body. So this date over here must be in correlation with this date that we see down here. So I'll put that in there automatically now. So that is going to be the 13th of August down there, and that those two dates there must be the same. So what I'll do is I'll make them both red, just to indicate that those two will always match up. So irrespective of what the date is at GMT, this must then match up. So we've been given a DR latitude. Now you can tell from the latitude, if we're at such a high latitude, we're fairly close to the pole, and therefore there's a high chance that we might actually be able to see a body at lower meridian passage. Now in this case we have a longitude which is west. Okay, so our longitude is quite far west, and that of course will also come into play when we do our calculation. So first things first, we can enter the almanac on this given date. Now I've checked before, if we've got this longitude using the date on the almanac, we know that we should end more or less on the same date. We're going west, so therefore we'll be adding. So our GMT time will be probably around about midday on that same date. So we go into the almanac on the 13th of August, and we find the actual LMT, the approximate LMT then for lower meridian passage, and in this case it's 5 minutes past midnight. Now it's very important for us to note then that when we're dealing with lower meridian passages for the Sun, we will know that it'll always fall around about midnight. So that's the only other difference really with these kind of questions when we compare them to upper meridian passage. So upper meridian passage, we know anywhere you are in the world, the Sun is at upper meridian passage more or less around noon. So therefore 12 hours apart, or 180 degrees apart, it would then obviously be logical that the Sun would then be at low meridian passage at around midnight, wherever the observer is in the world. So in this case we've got a western longitude, so we're going to go from the local time to Greenwich, therefore we need to add. So we're going to be adding the longitude over here converted into time, and that's going to give us 9 hours and 57 minutes. Alright, so we can add that together, and now we can see this will stay on the same date. So it stays on the 13th of August. We'll add that up there, and that's going to give us a time there of 10:02. Got no idea why that's red. I'll change that back. 10:02. Alright, so 10:02 Greenwich time approximate will be low meridian passage for the Sun. So we've got to apply our zone difference now. That's the last thing over here. So our zone difference is in time zone W, time zone whiskey. So therefore we need to then subtract 10 hours, because we're going from Greenwich back to the vessel, back to the observer. We're going to subtract 10 hours there, and that's going to give us then an approximate time of 2 minutes past midnight. 2 minutes past midnight on the 13th of August. Now, with none of these additions or subtractions here, the date actually changed. So that's perfectly fine. That means we ended on the 13th of August, and like we said, we want that to be in correlation. So those two dates must always be the same. Now this one over here I will highlight in yellow, and the reason for that is just that if we're going to be calculating now anything regarding hour angles, and especially when we're coming down to Greenwich hour angles here, it's very important that we must use the same date as it was at Greenwich. So if there was a date change here, if there was a date change and this was the 12th or the 14th, then that would have been the date we used when we actually entered the table to find GHA. Okay, but in this case it's not really important, but I'll leave it yellow in any case just to distinguish between the two. So we said that for lower meridian passages, the only real significant difference is the 180 degree LHA. So we're starting at 180, we've got a west longitude going from local to Greenwich, and therefore we will be adding. So we'll add 149, which is our longitude, we'll add that to the LHA, and that's going to give us a Greenwich hour angle for lower meridian passage, which is at 32912.3. So now all we need to do, we got to go into the almanac and we got to find the tabulated GHA on this date over here. So on this 13th of August, we're going to find the tabulated GHA that's closest to and also less than 32912.3. So we go into the almanac on that date, we find the GHA, and the GHA is actually quite close. It's 328 degrees 46.4 minutes. This will then be on the 13th of August, which is again matching to that, and that will be at 10 o'clock in the morning. So there you can see the 10 o'clock in the morning and the 10 o'clock in the morning there. They also add up. So we can simply subtract those two. That gives us a very small time increment, so we're not going to have a very big change in time here. So 0 degrees 25.9 minutes, and then we're looking at the total change. So the total change from 10 o'clock, the tabulated GHA at 10 o'clock, to the tabulated GHA at 11 o'clock, which is 15 degrees 00.1 minutes. So it's still, because we're dealing with the sun, it will always be approximately 15 degrees. So 1500.1. Now that's going to form a fraction, and that fraction, or decimal fraction, that we will then convert into a time increment. So that's exactly what we did here, and that basically gives us an increment of 0 hours, 1 minute and 44 seconds. This of course has to be added in order to find the actual GMT then, which will be on August 13th, 10:01:44, and now we can call that Zulu, time zone Zulu. So 10:01:44, 10:02, that's fairly close, so that also gives us an indication that what we did up here was in fact correct. Now the last thing we need to do is then find the ship's time for that lower meridian passage. So we're going to be applying the time zone again, and in this case we're going from Greenwich, we're going back into the Western Hemisphere, so we're going back towards the vessel. So we will be subtracting the time, so we're going to be subtracting 10 hours flat, and that then will give us the date again at the ship, the time and date at the ship, which we know then must again be the same as this one in the question, which it is. So that will give us then a time of 0000, sorry, that should be 0001:44, and that will be in time zone whiskey. So 0001:44, which is very close to 0002. So that gives us an indication there that that is correct. And that is in fact all we had to do for this question. We needed to find GMT and zone time for the sun at lower meridian passage. So there's an approximate time, and there's our actual time. In the next calculation, I'll be looking at an additional item that can be added onto this question, and that will be to actually find observed longitude. So I'll see you guys around next time.